Hi guys and gals, here is the problem that I gave you today. We have our guy, I think it was Knight Aaron, right over here. And he's trying to rescue that princess in the tower. And he's going to shoot an arrow with a rope attached to it to the top of the tower, and she's going to climb down. Now the people are coming to get him, the soldiers of the evil king. Who was the evil king? The evil king Scotty. Anyhow, they're coming against him. He doesn't have a lot of time to do trial and error. He has to think it out mathematically. Now, if you remember what he used a little bit of math, and we haven't quite figured out how he did it or actually what he did yet. But that was the question we left off today. If the sun is shining there, we're going to have some shadows. And the shadows that he originally saw was he knows that he's 5 feet tall, which is right here, and that's the same length as his big longbow, his bow and arrow right here. Anyhow, that longbow, if he looked at his own shadow, would come out to 2.5 longbows. The shadow of him is 2.5 longbows, and he said, okay, I can use that knowledge because I know that the shadow cast by the tower comes out to be 20 longbows. And using that information, he has to figure out two things, and both of them are in red. The first one that he has to figure out is what is the height of the tower. Now, that's not really what he's concerned with at the moment. I just want to make sure we include that in our math rationale, our thinking, because we can't do this question without knowing the height of the tower. And next, we have to figure out what is the length of the rope he will need to attach to the arrow to shoot up to the top of the tower and rescue. It's not the princess, it's the Scholar Brook is what we use today. And there's Scholar Brook hanging out the top of the tower, and she needs to be rescued. Anyhow, that was our math question, and all of our information that we need is here, but we haven't talked about how to do it yet. So I presented you with a problem that you need to try to figure out how to do. So that was the start of this. And the next part that we're going to talk about is where we went next. So what we did is we drew this triangle, and remember it is a right angle triangle, and the three squares attached to it. I told you that the lengths of the units are 3, 4, and 5. It doesn't matter if it's centimeters, meters, whatever it is, it's 3, 4, and 5. So that's what it was. And I asked you to come up with some relationships amongst the numbers, and we looked at a few other triangles, and your goal was just to look at the numbers and see what kind of relationships you came up with. Anyhow, so when we looked at all three triangles that we drew, or all three pictures that we drew, our numbers were 3, 4, 5, or 6, 8, 10, or 15, 20, 25. Each of these were a set. And you were to find relationships among them. And I just asked. I didn't ask you to go any specific way. Find your relationships is what I asked. And I had some great answers. I didn't copy them all down, but I copied the first three. And someone said, I forget who it was, that in each series the difference between the numbers is a constant. So between 3, 4, and 5, it's a difference of 1. And between 6, 8, and 10, it's a difference of 2. And 5, 20, or 15, 20, 25, it's a difference of 5. So the difference between each set of numbers in each pair, or each triplet, I guess, of numbers is the same. So that was a great relationship that someone found. The second relationship is the perimeter of the triangle is equal to the perimeter of the smallest square. I typed that in wrong. It's the perimeter of the smallest square. Let me correct that right there. Anyhow, so in the case of 3, 4, 5, the perimeter of the triangle is 12. So the perimeter of this would be 12. And the perimeter of this square here is 3 times 4, and it's 12. And we had people check with all three boxes and all three sets of numbers, and it worked out. So that's a great relationship, again, by someone I forget. And lastly, they said that when they looked at each of these sets of data, they actually found a relationship going down. So if you now divide the numbers this way, they said the first set of numbers of the smallest square, they have a variable that it's a multiple of 3. And if you look, 3 will go into that number, and that number. The next one, they said there is a variable of 4. And it is true, the 4 will go into each of the terms evenly. And lastly, 5. And it works out for all the numbers we did that they'll go in. So the third relationship is the first one has a multiple of 3, second a multiple of 4, and the third one a multiple of 5. And those were 3 great relationships. I was very proud of you, the way you got those ones. But next, I said, well, let's look at all of the triangles or the squares that we have in relationship to their area. And that's where I want to go now. If we do the area of each of these, remember that area equals length times width. This will be 3 times 3. And that will be equal to 9. It's a little different. Before, one of the other questions we did perimeter. But now we're going to do area. Anyhow, this one again is length times width, but I might as well write it. It'll take 2 seconds. And that equals 4 times 4 for this triangle, and that equals 16. I'm going to circle them just so you know what answers we're dealing with. And lastly, length times width, because it doesn't take very long to do. 5 times 5, and that equals 25. So what I wanted you to do next, and we already did this in class, is look at these numbers, look at the circled numbers, and see if you can come up with a relationship between those ones. And there were a few kids that could find it, and I believe Jordan was the first one to come up, and Grace kind of helped. And I kind of cheated, I gave away the answer, but what you find out is if you add the 2 smaller squares, it will equal the larger squares. The area of square 1 plus square 2, square 1 plus square 2 is going to equal the area of the largest square. Area of square number 3. And lastly, what we did to finish this off today is we made sure that worked for all 3 of our shapes. Square number 3. Okay, so what we're going to do is we're going to check it out with our next numbers. Our next numbers were 6, 8, and 10. Length times width, I'll just quickly do them here. 6 times 6 equals 36. I'll circle that one. Might as well skip over to that. 10 times 10, obviously 100. Circle it so I know we're dealing with. And lastly, down here, length times width equals 8 times 8 equals 64. Circle that. And again, we're going to add the 2 smaller circles to see if it still works. Smaller squares. 36 plus 64, and it equals 100. So we'll go to our very last one, and then that's where we're going to leave off today and make sure we're ready for tomorrow. Our numbers were 15, 20, and 25. Just like today, I don't have a calculator in my hand, so I'm going to have to do this in my head. Length times width is 15 times 15. I'm going to break that up to make it easier. I'm going to do 15 times 10, and that's 150. And then I have 15 times 5, and that's 75. I add 150 and 75, and I get 225 right there. 20 times 20 is a little bit easier because we just get rid of the zeros for a few seconds in our mind. Anyhow, 20 times 20 is 4, or 2 times 2 is 4, and they add the 2 zeros, so 20 times 20 is 400. There's different ways to attack that, but I know that one's 400. 25 times 25 would seem to be a fairly impossible task. Let me do length times width equals. But I know that 20 times 20 is 400. But more importantly, I know 25 times 10 is 250. Now, if I'm going to break this up, what this would be if we break this up into easier numbers, 25 times 10 is 250, plus another 250, plus half of that, which is 125. When you put it all together, that's 625. Of course, you can use your calculators, but when you start to develop some mental math strategies, everything just goes quicker. Math doesn't become such a chore, but it just takes a little bit of practice and a little bit of knowing that you might get it wrong the first few times, and then it works out. And then we check our math and we find out that 225 plus 400 equals 625. That makes this all right for all three of our examples, and this is where we're stopping for today. Tomorrow, we'll attack this, figure out that there might be a formula to apply with it, and then we'll be able to answer our question about Scholar Brook in the tower. All right, pick this up tomorrow.